Hello everyone, welcome to Pre-Calculus Class 6. So we have these new things to do. First of all, we will announce the quiz 1 date and topic in our class. We will do it, but now I will talk about the topic. Actually, we can talk about that. Then review of real roots of polynomials. We have two new things: imaginary and complex numbers and complex roots of polynomials. So these are the two new things for this video. So let's begin. First of all, our quiz 1 is coming up, and quiz 1 date we will announce it in the class, which is TBA, to be determined, to be announced. So I will announce it in the class. Then length will be 60 minutes, and in class exam, our syllabus for quiz 1 is 4.1, 4.5, and 4.6. 4.6 is in this slide. So let's start. First of all, this is review. This is coming from our previous video or previous class, both thing. If you look at this polynomial function, so the process for finding the real roots of this polynomial function is this is the constant term. We will take the factor of the constant term, and we will take the factor of the leading coefficient, and if this is p and this is q, all the factors, then our real roots will be p by q format. So by this analysis, we found the real roots of this polynomial function. So this one. So possible real roots are, for this question, possible real roots are plus minus 1, because there is no 2, so there is no fraction here. That's why there is no number here. So the number is 1. So 6 divided by 1 means 6. That's why it is in this format. And if we plug in here all the value, then we will see for x equal to minus 1, one root comes, or the whole thing becomes 0, and x equal to plus 3, everything becomes 0. That's why x plus 1 and x minus 3 is they are the two factors of this given function. Now see, we have a new thing. We have a thing here: x square plus x plus 2. This is actually you can try to break it down, but this is tough to break it down, because we cannot simplify it anymore. If we want to simplify, then some undefined thing comes, the square root of negative thing comes. And this is the graph of the main question, this is the graph of this question, and this is the graph of this one. Because why this graph? Because you can see there is no x-intercept for this part. For this part there is no x-intercept. That means no x-intercept will come from this term. But we can introduce some new type of number. We can introduce some new type of number by which we can actually simplify it also. And let's introduce it. Let's begin with the basic. First of all, these all are the real numbers: natural number, integer number, rational. Then these all are algebraic. This is actually irrational term. This is this root 2 minus root 3. These all are irrational, and these are transcendental. Transcendental means both of these two boxes are irrational, but these are special numbers. These are called transcendental. Transcendental means you cannot express them by this kind of something. Or transcendental number means we cannot algebraically we cannot express them. So, and here actually there will be another box, and for that box we are introducing imaginary number. Imaginary number comes from the idea of this root of minus 1. From root of minus 1, if we consider this equal to I, then look at this, root of minus 9. Normally it is undefined. We write a root of minus 9 undefined. But if we consider root of minus 1 equal to I, so we can separate them. Minus 9 equal to 9 into minus 1. Then see, we can break them down. So root 9 into root minus 1. Root 9 means 3, and root minus 1 means I. Root minus 1 means I. So 3i. That means now we have some solution. We have some answer now. This is not undefined anymore. So this imaginary number helps us this way. Now then we have this extra part. This is called the complex number. This is the imaginary number, and this is one real part. Together they are called the complex number. Complex number means a plus bi format, where this is the complex part, this is the imaginary part, and this is the real part. Okay, real part. So if you combine them, it becomes a complex number. Some example is 3 plus 5i, then 8 plus 2i, they are complex number. So if I ask what is the difference between complex number and imaginary number, basically imaginary number is just only this part is the imaginary number. Complex number is a combination of imaginary and real part. So this is how we form the complex number. Conjugate complex number, let's discuss it. So let's discuss this. Conjugate of complex means, let's say if you have a plus bi, then this number's conjugate will be a minus bi. A plus bi, then conjugate will be a minus bi. This, if it is positive, there will be a negative of this, then we will call them conjugate of each other. See this one, 3 plus 2i, then 3 minus 2i. This is positive, this is negative. Everything else is same. That means they are conjugate of each other. Why they are important? The reason is, you will see complex number will actually come in conjugate form. That means pair. They will come in pair form. This one, if we multiply a complex number with its conjugate, then actually it becomes real number. See how it happens. This is 3. So a plus b into a minus b. This means what? A square minus b square. And if you have I square, from I square actually we get the real part. You can see 2 into I square. So this becomes actually, this is minus 3 2i plus 3 2i. So this middle two number cancel out each other because they are the same thing, and the sign is opposite. So we have them this way. Then see, this is 2 square means 4, then I square means minus 1. So 9, then minus into minus equal to plus, 9 plus 4 equal to 13. See, we multiplied two complex number with one number with its conjugate. They are not separate number, they are conjugate of each other. Then we have found some real number. This is how conjugate complex number works. Then this one's conjugate will be what? This is 6 minus I. This one's conjugate will be what? This one's conjugate will be what? So this sign will change, right? Everything else will remain same. This one, next one will be this one, next one will be this one. All right. So what will happen if we multiply with its conjugate? Look at this, and this will have some similar behavior. Think about it. Using complex number. Now see, in our previous math, we tried to break it down, and there was no more answer. But if we use it by our quadratic formula, minus b plus minus b square minus 4c divided by twice a, this is our formula for finding the roots. So you see a, b, c, we have the value of a is 1, value of b is 1, value of c is 2. If we put it here, then after simplification is some simple calculation. See, 4 into 1 into 2, that means 8. 1 square means 1, so 1 minus 8 equals to minus 7. Normally we used to write here undefined, square root of minus 1. So as negative square root, so we cannot do it, so it is undefined. But as we introduced the imaginary number, now we can do it, okay? Because now we have square root of minus 1 equal to I, then root 7 we can write here. So for the plus, one answer, for the minus, another answer. So we have found two answers. Previously we couldn't solve this. This one we couldn't solve. Now after introducing this imaginary number, now we can solve it. Another thing here, notice that complex, see this number is actually complex conjugate of each other. Everything is same here, just only the difference is this is positive and this is negative. That means they are conjugate of each other. The point is, now we can solve this. By introducing this complex number, we can solve it now. So this is the answer. Complex zeros of the polynomial function. So now see, let's say we have a function like this, 2i, these are the zeros of the function, 2i 1 0, minus 2i another 0, 3 1 0, minus 1 another 0. So how we will write this, how we will write the function? The rule is same that we studied in our other chapter, other sections. The rule is still same. So here it will be, this is 2i, so it will be x minus 2i. This is plus, so it will become x plus 2i. See here, This is 3, so it will be x minus 3. This is plus 1, it will be x plus 1, because if it is minus, it will be plus here. This is how we can form our function if the zeros are given. Now we cannot say they are real 0. They are not real. There is some imaginary part here, so they are not real. Then if we multiply them and if we continue this one into this one, if we multiply we get this one into this one, if we multiply we get this. Then if we multiply this and this again, then we get this. So our final answer is this. Final function is this. This is the function in the factored form. This is the function in the in some simplified form. Actually, this is also simplified. We can say. I mean, depends on in which direction we are talking about. So this is some extended form also, you can say. So complex conjugate pair theorem tells us they comes with pair. Okay, that means look at this. If someone tells you that some function has 3 roots or 3 zeros, then one is 2, another one is 4 minus 2i. Then what is the another one? Last one. As 4 minus 2i, we have an answer. That means there is another answer which is positive. Same thing which is positive because complex number comes with their conjugate. This one, if you have, that means there is another one like this in the opposite sign. Okay, this is the thing. Now this is the question and we have to factor it. So sorry about that. So this is if we break it down, we have normal process. Okay, normal process. Then we have plus minus 1, plus minus 2, and plus minus 4. And if we test it, if we check it here, which one makes the function 0, then we have this x minus 2 whole square, then x square plus 1. That means x minus 2 comes 2 times. That means for x equals to 2, one time it becomes 0. Then the remaining function again, in the remaining function, if you do again x equals to plus 2 comes. Total is x equal to x minus 2 whole square. Or plus 2 goes there 2 times. Two times we can work with this. Or multiplicity of 2 for this real 0. This is a function. For this function, real 0 is 2. For that 2, multiplicity is 2. That's why it is like this. Then we have some imaginary part, and this imaginary part. If we simplify it, then imaginary part will come. And then after the simplification, this is the part here. So the roots are 2, minus 1, and 1. These are the roots of this question. So this is how we can find them. Now in class, we can try to solve this. So write an equation of a polynomial function fx that has degree 4. That means there will be 4 roots. The zeros is I, then 1 plus 2i, and a equal to 1. So you see, 1 is I. That means another one is minus I. This is 1 plus 2i. That means another one is 1 minus 2i. So now we know all of them, and a is 1. That means we can directly put it here, a equal to 1. Then if we multiply them, the whole thing, by putting all of them, then answer will come to this. Like after the multiplication. Then this is the thing. And then we have another thing. This is the function given. We have to find out the roots. Then after finding the roots, then we can write it in the factored form, the whole solution. So you have minus 26. We can check for different numbers, the same method that we usually do in the maths. Then you will see at some point you will have some imaginary part, and we have to do the that imaginary part, and final solution will be like this. That means for plus 2, it will become 0 first of all. Then this is the imaginary part. This is another imaginary part. So this is how the answer comes. We will solve this in the class in detail. Okay, we will solve it in the class, or you will try to solve in the class so that we can understand all of them better. So this is the introduction, I suppose. This is the thing about this. This is the about this exercise, about these sections. And is there anything else I need to tell? I think these are good. One important thing is this slide. One important thing about this slide is this page is very, very important actually for developing your concept. for developing your concept in mathematics. This is very important that you all should have the concepts of this thing. This is called the number sense. You must know what are the natural number, what are the integer number, what are the rational number, what are the algebraic real algebraic thing, what is the real number, all of them together a real number. Then comes the complex number, and which one is subset of which one, we actually understand it. That means, see, integer number is here, that means this is also included in the integer. Okay, rational number is here, that means these are rational, but this also rational, but this also rational. but 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 natural number box is this, that means they are not natural number. None of them are natural number. Natural number is only this. Okay, this means this is why boxes are like this. Okay, this is why boxes are like this. So this little box is really important for developing your concepts in mathematics. Number sense is really important. Just number sense, we cannot ignore it. Anyway, all right, thank you very much. I hope it works and it helps. Bye bye.